Today's topic is arithmetic progression. We take an example 1, 4, 7 and 10 and 13. Okay, so from this sequence we can derive many items. Okay, the first element is 1, the last element is 13. The difference between each element is that we call it jump from 1 to 4 is plus 3 and 4 to 7 the progress is plus 3. Like that you can observe the each element we have plus 3 plus 3. We call it this first element as A1, the second element as A2, this A3, A4 and A5. Here you can see the first element is A1 and the last element is A5. 5 means we can call 5 as n. This is an. Here n is equal to 5. That means we have total 5 elements in this arithmetic progression. The difference d, we call it d, the difference is plus 3. You can observe the difference throughout this progression is common. So here you know that a1 is equal to 1, d is equal to 3 and n is equal to 5. So from this progression, arithmetic progression, the statement 1, we can derive a1, that is the first number, then the difference, then the number of elements in this progression, that is n is equal to 5. And say for example, if we have given a1 is equal to 3, difference is 2 and n number of elements 4, we try to establish arithmetic progression using this. A1 is 3. Now to find the second element, you know that the second element will be A2 is equal to A1 plus D. That means this second element is first element plus 3. Like this, the next element will be the previous element plus 3. So the first element will be A1 3. The second element will be A1 plus D. That is 3 plus 2. That comes 5. Then the next element would be A1 plus 2D. So A1 is 3, 2 into D is 2. So 3 plus 4, 7. Like this, the next element would be A1 plus 3D. That comes around 9. So 3, 5, 7, 9. So here is n is equal to 4. This is the first element, 1. This is the second element, 2. Third element, the fourth element. That means n is equal to 4. Here comes around 9. So this is the arithmetic progression. Now if you observe, this is n is equal to 4. If you observe between this n is equal to 4 and this 3, this is n minus 1. That means to find out an, the nth number, an is equal to the first element a plus n minus 1. If you observe, to find out nth number 4, you have to deduct 1 from 4. That means n minus 1 into difference. This is the nth element you can find this way. This is formula number 2 and this is formula number 1, where you find out all the elements using A1, D and N, and this is the formula for arithmetic progression to find any nth number. An is equal to A plus n minus 1 into D. Now we know that in arithmetic progression we will have the first element A, the difference D and number of elements n. And we know the formula nth element An is equal to A plus n minus 1 into D. This is for the nth element. Okay. So using this formula we can establish any arithmetic progression provided the difference is common between all the elements. So now A comma A plus D, A plus 2D, A plus 3D, like that. This will go on till A plus n minus 1 into D. So this is the first element, this is the second element, this is the third element, this is the fourth element, like this. This is nth element, and you can observe the relation between this n and this multiplier here. So when n is equal to 2, that means to find a second element, so this is, we can take it as 1. 2 minus 1 is equal to 1. So to find a third element, we need to find out 3 minus 1 is equal to 2. Then multiply this 2 to the difference and add a to find a third element. To find a fourth element, okay, we deduct 1 from this 4, that is 3, and multiply this 3 with the difference, then add the first element to find a fourth element. Like that, to find a nth element, so we take it n minus 1 here, multiply that with the difference amount, difference number plus the first element. So this is the arithmetic progression formula. We can generalize using ADN like this. So AN is equal to A plus n minus 1 is into D. This is the generalized formula for arithmetic progression. Now we try to find out the sum here. Sum is S. Sum of arithmetic progression is, this is the first element A and this is the second element A plus D plus A plus 2D, third element, like this. This will go on, and here we add it n minus 1 into D. Okay, and we do one more sum here. The same element, we mention it in opposite way, reverse way. So this is A plus n minus 1 into D. So the last element we write it first, then the first element at the end. This is the last element. This is the last but second element. Like this, this will go on up to A. Now you know that this is the statement number 1, and the same statement in a reverse way, the statement number 2. Now we add both, 1 plus 2. That means 2s is equal to this a plus a, 2a, and here this is the first element, this is first element. So a plus a, 2a plus n minus 1 d. So this first element is first element plus this first element. We add both here. The first element we added a plus a, 2a, n minus 1 d. Now we add the second element and second element of this. Now you observe, if you observe a plus a, 2a, n minus 2, and here we have 1, n minus 2 plus 1, this again it will become 2a plus n minus 1 into d. So like this will go on till, if you add last element here, this is the last element and this is the last element, 2a, a plus a, 2a, n minus 1 into d, n minus 1 into d. Now 2s, so this 2a plus n minus 1 into d, this will go for, this is the first number and this is for the nth number. So this is like, this number is repeating 2a plus n minus 1 into d. This number is repeating up to n. That means we can write it, instead of writing all the digits here, we can multiply that with n instead of writing all the numbers, because this is repeating n times, 2a plus n minus 1 into d into n. Now 2s is equal to n into 2a plus n minus 1 into d. Now n into, we split 2a into a plus a plus n minus 1 into d. Now if you see a plus n minus 1 into d, this is the last digit of this arithmetic progression. So we can also write this as an, that means nth digit of the arithmetic progression. That means 2s is equal to n into a plus this, we call it an, that means nth digit. This is the first digit and this is the nth digit. Now s is equal to n by 2 into a plus an. This is the sum of the arithmetic progression. So this just, we added 1 and 2 here. By adding 1 and 2, we get the statement number 3. S is equal to n by 2 into a plus an.